Hello everyone. Today we are going to start our new lesson from grade 10th, electric field. So electric field is the same like that of gravitational or magnetic field that you have studied in your previous classes. It is represented through arrows showing the direction of the electric field. And we know that in every charge they have electric field around, whether it is positive or negative charge. Both have electric field. The direction of the electric field within a positive charge is away from it, and that of negative charge it is shown as towards it. Magnetic field, on the other hand, is also a type of field. And we will study later on the relationship between electric and magnetic field. In the same way, the source of the electric field is electric wire, loop of electric wire, solenoid, bar magnet, and earth. These are the magnetic field sources. On the other hand, there is another sort of field, that is the gravitational field. Gravitational field is related to the huge object like Earth, Sun, planets. These huge bodies in the universe, they have a field around it, and we call this as gravitational field. Now, what is electric field strength? Electric field strength at a point is equal to the force experienced by a unit positive charge placed at that point. So the electric field strength is equal to the force experienced by a unit positive charge at a specific point. The electric field strength is force per unit charge. It is a vector quantity. Why? Because it is a force per unit charge. Its formula is electric force divided by unit charge. And the unit is Newton per coulomb or volt per meter. And we will study it later on, that how this volt per meter comes. Electric field due to a point charge. Now this shows a relation between two electric charges and their effect on each other. Suppose there are two charges. What would be the effect of one charge over the another charge? To find the field strength near a point charge Q1, we have to imagine a small positive test charge Q2 placed in the field and determine the force per unit charge on it. So we are going to find the electric force per unit charge of these two electric charges. The force between the 2 point charges is given by F is equal to Q1, product of two charges, divided by constant value, that is 4 pi epsilon naught multiplied by square of the distance between these two unit charge, as we have studied in the Coulomb's law. The electric field strength due to the charge Q1 at a distance r from its center is thus E electric field is equal to electric force divided by unit charge, and this electric force, by putting the value of electric force, it is equal to product of two charge divided by constant value, that is 4 pi epsilon naught multiplied by the product of their resistance and charge 2, that is Q2. So what would be the effect of this charge on this, and what would be the effect of this charge on it? We can find through this equation. So or electric field is equal to Q over 4 pi epsilon naught r square. So these two charges are by cancelled. The remaining would be one charge Q divided by 4 pi epsilon naught multiplied by the product of their distance. The field strength is not a constant. It decreases as the distance increases, as the distance between the charges increases. The field strength obeys an inverse square law with distance, just like the gravitational field strength for a point mass. The field strength will decrease by a factor of 4 when the distance from the center is doubled. So we know that there is an inverse relation between the electric field and the distance between the charges. Is that clear? So if electric field increases, the distance if the distance increases, the electric field strength also decreases. There is example, a metal sphere of diameter 12 cm is positively charged. The electric field strength at the surface of the sphere is 4.0 × 10⁵ volt per meter. Draw the electric field pattern for the sphere and determine the total surface charge. So this is the unit charge, and the electric field strength is given for you. You have to draw in the same manner. Electric field is 4.0 × 10⁵ volt per meter. Radius, distance between these two charges, 12 cm. Diameter is given, and so we can find the radius as diameter divided by 2. It would be equal to 0.06 meter. We need to find the charge. So we know that electric field is equal to charge over 4πε0 multiplied by square of the distance. Putting the value, arranging the equation and putting the value, we will get the charge to be 1.6 × 10⁻⁷ coulomb, or 0.16 microcoulomb. Now there are 3 point charges are placed on the x-axis as shown in figure. Find the net force on the -5 coulomb charge due to the other charges. So there are 3 charges. One is 3.0 microcoulomb, charge 2 is -5.0 microcoulomb, charge 3 is 8.0 microcoulomb. And they are separated by the following distance. So we need to find the net force on between these 3 charges. Now because unlike charges attract, the forces on the -5 microcoulomb are as shown. The magnitude of charge 3, discharge, and charge 1 are given by the Coulomb law. Coulomb law, we know that is equal to K(Q1) product of charges divided by square of the distance. Putting the value, we will get the charge electric force. The electric force on charge 3 would be 3.4 Newton. Okay, so this charge 1, 3.0 microcoulomb, so 3 × 10⁻⁶ multiplied by the 5, this one 5 microcoulomb divided by distance, and this is constant value. And now the electric force between these 2 charges, 8 microcoulomb and 5 microcoulomb. So the electric force between these 2 charges would be 4 Newton. So I hope that you have understood the lesson. Stay happy and do study. Goodbye.